Okay, welcome to Science of Flight. We're now on Chapter 4, which is page 261. And let me call up the content. This main chapter here is our final chapter this year in Science of Flight. We want to, come on baby. There it is. We want to make sure we go through this chapter prior to finishing our study of aviation, and we're actually going to be going through a study and a challenge of a series of crashed airplanes that made mistakes navigating. And so this one chapter about navigating, flying from here to there, is going to be important on the crash investigation. The outline of this chapter, it has 5 different lessons. Yes, ma'am.
Hi. I have a Jerry Dufresne in the front office.
Okay.
That's here for you. So what?
Great. Tell him to leave the stuff. I'm in the middle of a class.
Thank you.
So we're going to go through 5 different lessons. You're not going to be tested on this in the this quarter. It'll be after spring break because this is a long chapter. But today we're going to go over and start talking about lesson 1, which is navigational elements. And then navigational flight aids. How do you actually fly and navigate in the middle of the area? The biggest thing about flying and sailing, because sailing is like flying, is your winds. Of course, when you're sailing, you worry about the currents of the ocean and the winds. When you're flying, the currents of the air, of course, is winds. Oh, by the way, somebody asked me this morning, why does the wind blow?
Going on the Earth's surface.
I joke because I had a cadet that I hadn't seen in a few years, and he said that's the one thing he remembers from 4 years of being with me is why the wind blows. We're talking about flight instrumentation. How do you actually know where you are when you're flying? And of course, the navigation technology and the fact that when I started flying, which was 1982, I guess, 81 was the first time I flew, so that's 30 some odd years. It's unimaginable what is sitting here in your hand. And think about what will happen for you guys in the next 30 years. Unimaginable. So we'll go through that. One thing, this lady, this quote here at the bottom, Anne Morrow Lindbergh. Who was Charles Lindbergh?
First person to make a transatlantic without visual, across the Atlantic Ocean.
Oh, give me air 5. There you go. Great job. You're exactly right. Charles Lindbergh flew across the Atlantic, first person, non-stop, unrefueled. And this was his wife. And basically she said, no signpost. There are no signposts in the sky to show a man has passed that way before. There are no channels marked. The flyer breaks each second into new uncharted seas. And that is quite true, even to today. When I would be flying, you sit there and look at clouds, you look at weather, you look at pictures and views that people have never seen before and will never see again. It happens so quickly. So we will go through that. All right, page 262. There's a good story here about World War I. Okay, what kind of planes were flying in World War I?
French planes, sir.
French planes, yes, and British planes. What were they made out of?
Wood.
Wood. Yes, you're exactly right. And what were the wings made out of? Wood. So we just had plain wooden planes.
Fireballs.
What were the wings made out of? Aluminum? Cloth. Yeah, I mean like fabric. Okay, so they were fabric planes, wood planes, and guess what? They had no idea how to navigate. Okay, they had no sense of navigation. The joke in my generation is they flew IFR. What does that mean? Eyes, close, eye forward. IFR, I follow roads. Okay, that means I follow roads, IFR. And so when you're flying in World War I, they just invented cars, right? And they barely even know how to ride cars. And all of a sudden you're flying and you're looking down at horses and carts. You follow the roads to get there. So this story here talks about World War I in Europe. 6 planes took off to attack a bad guy field. They got lost. They looked down through the clouds. They saw a field. They landed, and where did they land? In a bad guy field. So they didn't even attack it. They landed in the wrong field and got captured. And again, in order to replace the planes, which in World War I were very valuable, they had messed up simply by not being able to navigate. Oh, by the way, after World War I, say the 1920s, they had a lot of extra planes, right? Because we had finished the war. It was the war to end all war, and they had lots of barnstormers cruising around America in planes. How would they navigate? How would they navigate? Bless you.
Find the next barn.
Find the next barn. That's probably true. You'd laugh, but that's exactly right. But if I'm flying around, like, say, Arizona, okay, and I'm looking over and I see a community, that looks really neat, but they didn't even have maps, really. How would you even know what the name of the community was that you flew over?
You would land and ask the people.
That's true, but that kind of wastes gas and time, but how else would you know?
Peeking up the mountain like they...
Oh, give me Air 5. There you go. Yes, they started putting silly things that I think are hilarious, like peas on the mountain, like our Pea Mountain. When you go to Aho, what is the sign of that mountain?
Oh.
That was a trick question. A-H-O is how you spell Aho. What about Seligman? S. Okay, and did you know even in Phoenix, there is a mountain to the east side that has a big Phoenix in white letters and an arrow. Yeah, which means it was heading towards the Phoenix airport, where you're supposed to land. Of course, it did help that in the 1920s with these planes, they could land anywhere. You didn't have to, there was no paved runways at the time. You just landed on a field. But also another thing to help navigation back in the 1920s was they actually had water towers with the names of the communities on the water towers, right? So you go circle around the water tower and it says Prescott, you go, hey, I'm in the right place. Can you imagine navigating without any maps or not even knowing where you are? So that was exactly how they started in the flying world. What I'm going to talk about right now for about 10 minutes is how to navigate in general. How do we actually know where we are in the world? Anybody ever seen this before?
Yes.
That's to Earth.
What is it?
Earth.
United States upside down.
You're saying it's upside downwards. Why is it upside downwards?
It's not. Because you can gyrate it.
But where is south?
Down.
Why do we have south down? Why do we not have south up?
Because it doesn't make sense.
Because of the...
It doesn't make sense to your brain, but why?
Because
Because
poles have
Magnetic
force.
But how come your brain says that north must be up? Why can't we have east up?
Oh, because we
Depends on where you're facing. Yeah.
How come when we look at a map,
It's usually pictured.
it's usually a picture of America? Why don't we have a map with Africa with east up?
It's traditional.
It's traditional, it's true, and it goes back hundreds of years of how we make maps. But the point is, when we do maps, guess what? North is up, okay? And because we're in America, we do north is up with America being in the northern hemisphere. How do we know where we are in the world?
Because
Longitude and latitude.
Ding, 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 ding. Longitude and latitude. Let's see, that's somewhere in here in the map. Okay, how about page 266, 267? Longitude and latitude. What is longitude and what is latitude?
longitude is the directional, like measure, yeah, and then latitude from north to south.
Okay, so big picture. We have a ball called Earth. Okay? Jeff Pierce, which way do longitude lines go? Guess, I don't know.
North to south.
Okay, so north we're saying up here and south is saying here, and you're saying that longitude lines go like this.
Yes.
Is she right?
No. I don't like it.
It's from latitude and then altitude.
Longitude, definitely go north to south. Give me her 5. Good job, yay. So which way would latitude go? Latitude goes like a ladder. That's how you remember it. Longitude, north and south, ladder up and down. Here is the question. If we have longitude lines going up and down across the world, which lines never change in length?
Both of them.
Both of them.
The
Prime meridian, the equator.
Is prime meridian, oh, we're throwing out all these cool words. What's a prime meridian?
It's
Prime middle one.
Is it a longitude or latitude?
Latitude.
I hear 50-50. I love it. Okay. This is really a good one. All right. First of all, my original question was, out of the longitude and the latitude, which never changes in length? Longitude, latitude.
Meridian is 0 degrees longitude and is
The
aligned
prime
with
meridian
longitude that
and the
runs
equator.
green.
Look at the picture. We have the world. The latitudes go like this. The longitude goes straight up and down out of the North and South Pole. Which lines never change in length?
Middle.
All of them. Excellent guess, but wrong answer. Let's say I am sitting here on the equator, and this is the latitude. This is 0 latitude, right? On the equator. How long is that line?
Around the world.
How long is the equator?
4,000 pi.
25,000 miles. Okay, about 25,000 miles. Okay, so let's say I walk down to the South Pole. Oh, by the way, is South Pole ground or is it ice?
Ground.
There's really ground under the South Pole. There's a continent down here. Is there a continent in the North Pole? No, it's just ice. And by the way, it's going to be melted in a few years due to our global warming. You guys will be able to go vacation up there. No problem. Probably the South Pole too. But anyway, so we're down at the South Pole and we're standing on ground. Of course, it's a mile of ice right this second, but in your life, it'll all melt away. And so we're here on the ground, and this right here, that is the South Pole. I want to walk around the South Pole in that latitude. I walk around that on that latitude. How long is that latitude line?
The 7 is the north.
Excuse me?
Short.
Short.
Like you.
So which lines never change in length? Longitude or latitude?
Two can have the same start and end point.
The longitude always go from north to south pole. Okay? Latitude lines can get very fat and very long at the equator. And they can be, 2 inches long at the South Pole. Over 1 point, they can be infinitely short. Do you understand that these lines vary where they are on the Earth? These lines stay the same because they go around the entire Earth? Which brings you to a question of how to measure the Earth. When you measure the Earth, we measure the Earth with the distances between the latitude lines. 1 degree of latitude is exactly the same up and down, and it's 1 nautical mile. We'll get there later on this time. So if we look at the picture of the world here, and we actually think about, let's say, time zones. How many time zones are in America? Okay, we're looking at time zones. How many time zones are in the world? 24. How long around the equator?
25,000.
25,000 miles, 24 time zones. So how wide is every time zone?
About 1,000.
About 1,000 feet, about 1,000 miles. Give or take. And how many degrees are in a circle?
360.
Yay! If you divide 360 by 24 time zones, how wide is each time zone about? 360 divided by 24.
15,000. 15,000 minutes. Sorry.
How many degrees is each time zone? Hello, Ted Buell, Smith. What is 360 divided by 24? Do your math.
Bolton's
Do math. What is 360? Cadet level. What is 360 divided by 24? Do the math. I see you doing something. Do math. Yes. 15. So, I guess I'm going to put that on the test, okay? So, my point is, if you look at this chart, it's about 15 degrees of longitude equal about a time zone. When we're sitting here in Arizona, and it is 9:25, what time is it in Washington, D.C.?
11:25. Washington D.C.
Washington, D.C.
11:25.
Is it
25.
plus or minus the time zone? Plus, yes, exactly, because you're going east. Oh, by the way, you realize we are very, very weird in Arizona. We are not normal. What do we observe? Daylight savings time. We are the only state that does it. Are we the only place in America that does not?
No.
No, there are other counties, I think in Indiana, I don't know, that's a good question,
Indiana.
somewhere that does not do it. But here's another trick question. In Arizona, does the entire state not observe daylight saving time?
No.
Who observes it?
Everyone.
Everyone but
No, in Arizona, does every citizen of Arizona not observe daylight savings time?
we don't observe it, so yeah.
We don't do it, but does every citizen not observe it? Farmers change their clocks?
Yeah.
No. Actually, we have nations inside of Arizona, which are called Native American, nations. The Navajo Nation does observe daylight saving time. The Hopi Nation, which is inside of it, does not. So if you were to go from here to the Hopi Nation, you would go from 9:30 to 10:30 and back to 9:30 if this was daylight savings times. Yes, sir.
What if someone that lives in there has to plan something like outside of just that reservation?
You have to have your act together, and you call it Arizona time, or you call it res time, reservation time. Yes, it's a fact. Okay, what about the entire world, guys? Are these time zones just like straight?
No.
Who determines the time zones? Look at these time zones. Well, who determines what time zone you're on?
The people around you.
The countries. The countries can choose to have the time zones. You see, actually, America does not have 4 time zones.
How does it?
1, 2, 3, 4, Alaska 5. What about Hawaii? So I'm telling you, there are different time zones. I think, go ahead, what question?
Okay, like I understand it's like the way it goes because of the noon being there, but how does it work? Because if you look at like goes all like the colors and time zones go like all out. It's gonna be,
How does it work? Each country determines what time zone it's in. And oh, by the way, over here in the Pacific Islands, this one line here is the international date line, which means if you're flying on a plane going from, and you can read it right here, if you're flying on a plane going to Japan from west to east, you add 24 hours as soon as you cross this line. So you go from Wednesday to Thursday as soon as you cross that line. It goes from 9:30 Wednesday in the morning to 9:30 Thursday in the morning right now, right when you cross that line. So these little countries determine where they are on the time zone. And you lose it when you go west to east. You lose one whole day. You go back in time.
what's the bar?
What is the bar?
The bar.
You mean this right here?
No, in Australia.
Oh, what is this bar? Well, guess what? It says 9.5. So they don't have hour time zones. They have 9.5 hours. They have half-hour zones. A little different. Okay, we will stop it now, and we'll continue this Tomorrow, it gets a little more complicated, but I want you to